Hello again. In this video I will be solving an example related to Kirchhoff rules, and I'm asking you here to calculate the current through each resistor. So I have 1, 2 and 3 resistors. They are connected in a certain way with the two batteries, two different voltage. Alright? Now, to do such things and following Kirchhoff rules, we need to remember that in Kirchhoff rules we have two things. One is the junction rules, where I will be distributing the current through a junction. So if I say I will pick this junction here and on the top, I can say current 1 is going in. Now I can decide that current 2 also going in. That will give me only one choice for current 3, which is going out. Alright, let's continue the distribution here. That is I1, I1, for I2 will be I2, and also I2 here. That's again I3. So following the first rules or the junction rules, I1 plus I2 equal I3. That's first rule, or the first equation we will have from this question. It's total current in equal total current out. The second one is the loops. So I can decide the loop in which direction. So I will take the left one going clockwise, and I will call it loop 1. And also I can choose the same direction clockwise for loop 2. Okay, now we need to follow the scenario of loop 1 and loop 2 for the second rule, where the total voltage in a loop equal 0. Now if you saw my previous video for one loop, practically I am choosing one loop a time to solve these equations, or to find or write these equations of Kirchhoff rules. So if I take loop 1, technically I am focusing on the left loop. Once again, it is going to be a positive 8 through the battery. It is going to be negative 4 I1 going opposite the battery. That's, sorry, my bad here. It will be negative 12 going through this second battery, voltage 2. And for resistor 3, I am going also to negative 6 I3, and coming back where I started. That will be my first equation. Of course, you can do that. That's a positive, that's a negative, that's a positive here, that's a negative, and here the other way around, positive and negative. Okay, you could do that. Now let's make sure this equation is more simplified. It's going to be minus 4 I1 minus 6 I3. That will equal 0. That will be our second equation. Okay, let's go to second loop, where I have second loop, the one on the right. It is going to be clockwise, and I could start simply from anywhere. I could say, all right, I'll start from here, all right, and it will be a positive 6I3 plus 12 through the battery, going up and turn right, nothing there. Again, we're gonna get to circuit resistor number 3, and it's again, it will be positive 8I2, and when we come back, everything will be equaling 0. So that's my second equation, or third equation actually. Just for the lock prefer to write the voltage first. 6I3 plus 8I2, that's equal 0. That will be our third equation of Kirchhoff rules. That's all the equations I need. I have 3 equations with 3 unknowns, the current one, 2, and 3. Now, it is time to try to solve these equations and find the answer or the value of every single current. To do that, I need to look carefully and find my key to these things. So if I look to equation 2 and here and equation 3, I'll find that there is a common element between them both, which is, I'll put a circle around it, it is I, or I'll underline it, it is the I3. Current 3 is the common between these two equations. I could use equation 1 to help me having or modify equation 2 and equation 3, where I will have only the unknown current 1 and current 2, then I will do the elimination. So let's do this. I will be now replacing the I3 in equation 2 and I3 with the value of I1 plus I2. Okay, let's do this. So for equation 2, it will be like this. It is minus 4I1, and it will end with a minus 6I1 minus 6I2 equals 0. Now I have I1 here and I1. That will give me minus 4 minus 10I1 minus 6I2. That's equal 0. All right. That's the first new equation we have, or be modified. From loop 2, equation number 3, we will have 12 plus 8 I2 plus 6 I1 plus 6 I2, that's equal 0. I have I2 here and I2 here. This means it is 12 plus 6 I1 plus 14 I2. Great. That's our second modified equation. If you look now carefully, if I call this equation star and this one is 2 stars, I can eliminate one of the elements in these equations because they are both having I1 and I2. Okay, so what I'll do, I'll try to solve it here. Let's put them on top of each other. Minus 4 minus 10 I1 minus 6 I2 equals 0. And I have here the 12 plus 6 I1 plus 14 I2 and equals 0. So to do that, to solve this system, I need to try to find one of them or decide which one I will be eliminating. Well, I can decide I will be eliminating I2, the second current. Simply to make that possible, let's multiply the top one, or the star equation, with a positive 7, and double star equation, let's multiply it with a 3. And yes, we're going to do the addition after that. If we do that, we said our target is to eliminate the second current, which means 7 times 6, that is 42, but it's negative, and 3 times 14, I believe also it's 42. Excellent. So practically it's a negative 42 plus 42. That's mean this one here is gone. What I have left is 7 times minus 4, then I will add it to the second level, 3 times 12, that will give me 8 here. I'll change the color, minus 52i1 and equal 0. I can continue here. So from here I can find I1 equal 8 divided by 52, and that will give me I1 equal 0.15 ampere. Okay, now to find the current 2, or the magnitude of current 2, simply take this value of the current 1 and you can insert it in the 1-star equation or the 2-star equation. Doesn't matter, you just put it there and that will give you the second current magnitude, and it should be, when you do that, giving you a negative 0.92 ampere. Now the easiest one, I3, which was I1 plus I2, which is 0.15 plus negative 0.92. That will give you a negative 0.77 ampere. Alright, this is the way to solve a detailed Kirchhoff rules from the scratch, where you have let's call it a row circuit. There was nothing distributed, not the current, not the loop, so I decided to distribute the current through a junction in the way I preferred. Then I decided the loop direction, and from there I start writing the first equation and the 2 equations for loop 1 and loop 2, and modify things until manage to solve the system and finding the values of current 1, current 2, and the third current. Alright, I hope you find this video really useful with solving Kirchhoff rules, and I hope to see you again in another one. Thank you.